Hello everyone, next lecture of IC 141, Product Realization Technology. So today we are going to talk about ceramics. So what are ceramics and how they are, they are used for manufacturing purposes. Here I have pasted a picture of stones. So stones are all around you, right? You've seen them, and you have also seen bricks, and you have also seen, sand. All of these things, they are ceramic materials. So these are natural ceramic materials. In fact, some people also say that ceramics have been the oldest manufacturing materials because we don't know. See, when the humans started using tools, we don't know tools. They may have been wooden tools or they may have been just stone-based tools. Sharp stones can also work very well as tools, right? Also, when the civilization started to develop, then glasses became very important manufacturing materials. So glass and glass processing technology has been known to mankind for a very long time, for thousands of years. We can see glass beads and these kind of things during archaeological surveys and so on. All right, so ceramics are these materials which, if you can think of stone and sand, what are these materials? They are like powdery materials, although they are hard and brittle, so typically amorphous, but they can be converted into powders, right? So this is the general idea. This also works for glasses, although glasses can also be melted. So now we are going to understand today why I'm saying that glass and stone, even though they have very different properties, why are they both ceramics? Okay, and why we have different types of processing techniques also for ceramics. So this is what is the topic for today. By definition, what are ceramics? These are oxides or nitrides or sulfides, fluorides of metals. So basically, what are they? They are basically compounds of metals with some non-metal element. All right, so now you can already see the difference between an alloy or a polymer, different materials that we have already learned. In the case of an alloy, you will have two metals, but they are mixed together. They are just forming a mixture. They're not forming a compound. But here you are forming a compound, and that too between a metal and a non-metal. Okay, so this is why there are so many different types of ceramics, right? Because they can also be oxides, they can be nitrides, they can be, as you can see already, and of course the metal itself will change. So based on this, you can have a range of materials that are known as ceramic materials. They have different properties, like some of them are transparent, some of them are non-transparent, some of them are they have some very special properties like piezoelectricity. We are going to talk about all of these things. So we'll also learn how to process them and so on. Okay, so I said that simple examples of ceramics are stones and clay pots. So you've seen clay, right? And terracotta and these kind of things. So clay pots, bricks, the coffee mug, chai mug. This is my coffee mug. Okay, so this is also a type of ceramic. Porcelain, basically. A lot of porcelain utensils, all of these things they are made of ceramics. So this is one example. Glass, of course, glasses of all types. So not just the window glass, but all kinds of glasses. The glasses that people wear, the glass bangles that people wear, or what else? So you can imagine there are different things that are made of glass. So that's also one good example. Quartz, by the way, is a type of glass also, and sand and so on. So these are some common examples of ceramics. This is just to give you an idea of what are ceramic materials. But of course, when we use them now for industrial applications, for advanced manufacturing applications, what we call, then we have not just these materials, but also well-defined compounds of metals. But when I say well-defined, that means we know what we want from this material. We also know the exact properties that we expect. We also sometimes can induce a certain property by, let's say, adding another impurity or some other element into it. For example, if you want to add color to glass, you can add a little bit of something else which is not the primary material of that glass. So by changing a few little things, you can actually get, you can change the properties. And all of these materials, some of them are in fact very expensive materials also. And they have very special properties also. Some of them are also very strong. Most of them, however, this is the property common to most of the ceramic materials. They are hard and brittle, which is because they are amorphous or polycrystalline. So you will definitely not find metal-like properties in ceramics. They will not have a shine or luster. They will typically have a relatively rough surface. Of course, you can polish anything and make it, you know, a little bit more or smoother compared to what it was. But in general, they have relatively rough surface. So they are very different from metals. Also, they usually have very high melting points, or some of them don't even melt. They sublimate. They convert into vapor at very high temperature. So they do not pass through a liquid state at all. So these are some of the properties of ceramic materials that make them different from metals, definitely different from metals, and also from polymers. Of course, they are different. Why? Because polymers have these long chain and sheet-like structures, and in the case of ceramics, that's not the case. You have like molecules. You don't have atoms. You have molecules, but these molecules are simpler, relatively much simpler compared to you know, if you compare them with polymers. For example, silicon dioxide or zirconia, which is zirconium dioxide, and so on. It's not ZiO2, it's ZrO2, by the way. So there are some of these examples that I have mentioned on the slides. All right. So now in terms of bonding, the ceramics are inorganic compounds. So they can contain carbon, but they are not just carbon, hydrogen, oxygen, nitrogen based compounds. They always have a metal, and they often have also a range of non-metal you know, elements, not just limited to what we have in the case of organic materials. Okay, so now since they are inorganic, they also often have ionic bonding. In fact, in most cases you have ionic bonding, very little covalent bonding, but here and there you can find it, but primarily it is going to be ionic in all cases. Okay, so this I have already told you. They are typically amorphous or polycrystalline, and they have very high melting or sublimation temperature. So this is one very important thing about ceramics, is that they are used for protecting things from temperature related problems. So ceramic coatings, for example, can withstand very high temperature. So most of the ceramic materials can withstand high temperature. So they are temperature resistant materials. So that is why they are often used for high temperature applications. This is one very important thing. They are also good conductors of heat. Okay, so they can withstand high temperatures without much deformation. So that anything can withstand high temperature, but if it deforms, for example, metals, you can also say that metals can be heated to very high temperature. High here we mean, you know, above 1000 degrees centigrade. That's what we mean by high. You will say that there are many metals, I can heat them to up to 1500 degrees centigrade, but they might melt. There are very few metals that can withstand 2000 degrees and above, but many ceramics can withstand up to 1000 is common for ceramics. So up to 1000 degrees centigrade. Now these ceramics, however, I'm talking about these opaque ceramics, and just leave glasses out for the time being, because glasses can melt at some glasses can melt at a lower temperature. So there we have melting, but in this particular case, so the examples that I have mentioned here, alumina, for example, they can withstand 1600 degrees centigrade and so on without any deformation and without any expansion. So metals can also withstand high temperature, but they will have some expansion, and in fact we also know there is a property known as thermal expansion and thermal expansion coefficient. So what is the definition of thermal expansion coefficient? How much does anything expand when we increase, you know, 1 unit temperature? So something like that. If you compare with, you know, compare a ceramic material with metals, in that case ceramic will have high or low. It will have a low thermal expansion coefficient. That means it expands very little or negligible compared to metal. So for example, alumina will have its you know, thermal expansion coefficient is almost twice as low as that of you know, steel. So that means it is half of that of steel, right? And even lower in some cases. So it also depends on which type of steel we are using. The point is that the very important thing that you need to know about ceramics is that, in terms of its properties, is that they can withstand very high temperatures. They are very good materials for high temperature applications, leaving glasses out of it. Okay, so now every time I'm saying leave glass out of it, means that must somehow belong to a different type of ceramic, right? So this brings us to the classification of ceramics. Okay, Again, like polymers, like metals, alloys, we can do classification various different ways. So there are, one method, for example, is based on the chemical composition. Now, of course, this is something we can do. Oxides, nitrites, this is easy, right? Because these are all different types of ceramic materials. So we can also classify the materials accordingly, according to their chemical composition. That is one way of classifying it. Now, what else? Based on the physical property also we can classify them. So physical property like transparency, so transparent and opaque are two different types of ceramic materials. So stone and glass, for example, right? So this is one method also where you can separate. For example, you can have different classes. Transparent ceramics, so we put all the glasses in the transparent ceramics. Whiteware is the coffee mug, the porcelain kind of material. That can be one class of ceramics, which is, by the way, again, one of the oldest materials that has been used by humankind. Okay. What else? There is also something called porous ceramics. So you know what are pores? Pores are these little holes in any material, right? And these holes are distributed everywhere. They completely change the property of a material because these things which have pores will have a much higher net surface area. And they, in most of the cases, when something is porous, that occupies a lot of volume. So like sponge, right? It occupies a lot of volume, but actually the volume is not, actually the mass is not very much, right? So the content, the material itself is not there so much compared to the volume that it occupies. That means these things are often very lightweight. So we also have porous ceramics. And what can you use porous materials for? Of course, for filtering purpose, for absorbing something. So for all these applications, you also have porous ceramics, so some ceramic materials based on their manufacturing process also, which we will learn in the future. They can be made porous. So this is another class based on the physical property. What else? Some ceramic materials are only used as thin films. What are thin films? Well, anything that is used for coatings. It's a very thin. We call something thin when compared to its length and width, the thickness is negligible, right? That is what we call as film. So now if we have thin films of ceramics, there are certain ceramics which are particularly used, specifically used for making films and not for anything else. So that can also be one class of ceramic materials. What else? Then you have some very advanced ceramics like they have photosensitive properties. You must have seen photosensitive glasses, right? Some people, nowadays I don't see it so much, but people used to wear these glasses when they go out in the sunlight, then the glasses become dark, then they come inside the house, then again the glasses slowly gain the transparency back. So those kind of glasses, they are also ceramic materials, right? So you can have photosensitive ceramics. Nowadays people don't use it so much in their glasses, rather they are used for a lot of sensing applications. So it's not that those glasses have completely lost their applications, but not in the common applications so much anymore. I don't know. Nano ceramics, again, these ceramic materials contain nanoscale structures. We'll not go into the details. I just wanted to tell you these are some of the examples. Bioceramics and others. Bioceramic, by the way, what are our bones made of? Our bones are also ceramic materials. And that's why bone implants or teeth implant, they are also made of ceramic materials. And these kind of ceramics which are biocompatible means they don't really harm your body, they are not toxic. So these kind of ceramic materials are known as bioceramics, and then there are some others also. So this is one way of classifying. What are the other? So there are more. Okay. Chemical composition, physical properties, and then processing techniques. Processing techniques we are going to learn. There are certain techniques that are traditional because, let's say, clay has been there for a very long time. People have been making pottery and so on. Certain techniques are still more, they are closer to the traditional techniques, but there are also, if you want to make machine parts and tools and electric insulators and so on, in that case, you call these new or advanced ceramic materials, you call them as engineering ceramics. And of course, their processing techniques are also different. They are processed using certain machines and tools and so on. And that is something which we also do in the workshop, which is a part of your course. So this is yet another classification pathway. Finally, based on the application. Okay, glasses have their own applications, clay products, refractory materials, abrasives, cements. So these are the 5 things that I have mentioned here. They are the primary applications of ceramics. There can be many other applications as well, but these are the main applications. And now I'm going to give you the details of each one of them. So what exactly do I mean by a glass? Okay, so till now you know what is a glass, but how do you define a glass? These are amorphous silicates. So by their chemical composition, they are typically silicon based or silicon oxide based materials. So these are silicates. And they may also contain, for example, for adding color, you may also have some other oxides added to them, and these are some examples. So this is the official definition of glass. Okay, what is clay? Clay is mainly sand and clay. These are silicon oxide, silicon dioxide, and that is called silica. Now, silica is not the only thing in clay. Silica, alumina, and magnesia, these are some of the primary, all of them are oxides. So these are some of the primary components of your clay type material. However, depending upon where do you find the clay, you can have various minerals. In fact, there is a class of minerals that is called clay minerals, and silica, alumina, magnesia, of course, are the most important ones, but they can be also, for example, in some places there is a lot of iron, so you can have compounds of iron present in your clay. So depending upon the location, you can have other minerals as well. Okay. What are refractory materials? We have already in the metals lecture, I briefly told you what are refractory metals. So refractory, anything is called refractory when it can withstand high temperatures. And these are the kind of materials which have a lot of several applications. For example, in mold making or making parts of a furnace, anything where high temperature things are going on. So ceramics are, in fact, they are the most common materials used in the refractory applications. So because they can withstand high temperatures, okay, and some examples I have mentioned here. Okay, now what is the other thing? So three things we have already discussed, and cement probably you already know. One thing that is left, or probably it's new for this lecture, is abrasive. What is abrasive? So the name already tells you something about it, right? It is hard, and these are hard and rough materials. Okay, hard and sharp and rough sort of materials. Okay, so they can scratch a surface, they can dent a surface. If you just take, in fact, if think about a very sharp stone. Okay, stone is a ceramic material if it is a very sharp one, or maybe people in the past used it as a tool. So if you take a sharp stone and then you try to make a scratch or dent onto something, you can easily do so, especially if the surface is that of a metal, anything that is softer than the stone. These kind of materials are known as abrasives. So why are abrasives industrially relevant? Why are they important for us? A lot of abrasives are used in the industry, engineering industries, for surface finishing, surface polishing. How do we do that? So let's see, in this image or in this illustration, you see that there is a rough surface. Okay, and I want to make it smooth. So what I can do is I can take these sharp little pieces. So it's like a powder of some sort of ceramic material, but not very fine powder. Depending upon what is the roughness of the surface, I can have very fine powder or a little bit rough powder. But there I have these sharp abrasive particles, and when I rotate them in all the directions like that, then afterwards I can get a smooth surface. Now this is something I call sandpaper action. So if you have ever tried this for fun, that you took a sandpaper and you tried to polish something, and then you made the surface smooth, that action, sand also is a ceramic material, and all of these kind of sharp ceramic objects are used as abrasive in many industries, and they are very very useful. This is a very important application of ceramic materials. And of course, finally, cements. So when I say cements, it includes concrete, it includes also plaster of Paris and limestone. All these things are cement or cement-like materials. So these materials, so these ceramics have a property that when they are mixed with water, and then when the water evaporates, so water leads to a certain chemical reaction. Once the water evaporates after drying, these materials harden. So you know that very well for cement, right? So these are all the different types of ceramic materials and different classifications.